Hello. Today we're going to be talking about function composition. So over the past few days, we've been doing function operations. We've added functions, subtracted them, multiplied, divide them. Today we're going to do another operation. It's called function composition. Think about if you compose music. You're putting together notes and chords and lyrics and everything like that to make a song, to make some music. So function composition, we're going to be putting together two functions to create a brand new function. So first I want to start with the notation. You may or may not have seen it before. So this is f of g of x, and this is g of f of x. So this means to take your g function and place it inside of the f function. This means to take your f function and place it inside of the g function. So again, f of g of x, substitute g into f, g of f of x, take f and substitute it into g. So let's get started with the first one. We're going to go this direction first. So f of g of x. This means I'm going to take the g function, which is 3x plus 2, and I'm going to substitute that into the f function. So we're going to keep the 2, get rid of the x and make a substitution, and keep the minus 4. So I'm going to keep the 2. I'm replacing it with what g is, which is 3x plus 2, and minus 4. So now if I look at this, f of x is equal to 2x minus 4. Notice I kept the 2. I just brought it down. I made a substitution, no different than if I was substituting a number into my function, and I kept the minus 4. So the only substitution that I made here is that I was replacing my variable with a new function, which was 3x plus 2. So however many variables that you have in your problem, that's how many substitutions you would make. Now we go through and do the distributive property and simplify. 2 times 3x is 6x. 2 times 2 is 4 minus 4. These cancel out. We're left with 6x. I can go through and do the same thing on the other side. So now I'm going to do g of f of x. Okay. Same thought process, but I'm going in a different order. This time I'm taking f and I'm substituting it into the g function. So this time I'm going to take 2x minus 4 and I'm going to make a substitution in for this x right there. So I'm going to keep the 3, make a substitution with the f, plus 2. So I kept the 3, that came down. I made a substitution with the x, that was 2x minus 4, plus 2, plus 2. So I'm replacing the variable with whatever the function is. And this is a separation here so that you don't get confused. So the left-hand side, I did f of g of x. And this time I'm going to do g of f of x. Go through, distribute. 3 times 2x is 6x. 3 times negative 4 is negative 12, plus 2. Negative 12 plus 2 gives me negative 10. So f of g of x gave us the result of 6x. G of f of x gave us the result of 6x minus 10. So you can, and probably most of the time, will get different answers once you go through and do composition both ways. Let's try another one. So I use a different notation purposely so that you can get used to seeing it different ways, but it means the exact same thing. So this means to take f and plug it into g. This means to take g and plug it into f. So the same notation that we did in the previous problem, but the symbols and notation are different. But on the next page, I will show you that they mean the same thing. So this means to take f and make a substitution into g. This means take g and make a substitution into f. So let's start with g of f of x first. So I'm going to take f, which is 4x plus 5, and I'm going to plug that in right there. So that's going to give me 2. Get rid of the x and plug in f, minus 5. So I kept the 2 from the problem. I got rid of the variable and I replaced it with the new function, which was f. and I kept the minus 5. Go through and distribute. 2 times 4x is 8x. 2 times 5 is 10 minus 5. And 10 minus 5 is 5. If I go through and do the other direction, this time we're going to do f of g of x. This means to take g and substitute it into f. So take 2x minus 5 and substitute that into f. So I'm going to keep the 4, make a substitution, and then add 5 to it. So I took g, which was 2x minus 5, and I substituted that into my variable right there. So that variable is no longer there. You get rid of it. So 4 times 2x is 8x. 4 times negative 5 is negative 20. Add 5 to it. And negative 20 plus 5 is negative 15. Again, you get different answers. Nothing's wrong with that. You won't have to do both directions for every single problem, but since we were just getting started, I did want to show you both directions. Now let's jump back into that notation that I was telling you about. So 2 different symbols that mean the same thing. So just depending on what the problem looks like, you may see it written different ways. You may see it written like this. So this means take G and substitute it into F, which is the exact same thing that this means. Take G and substitute it into F. So kind of think of it working backwards or working inside out. So if I'm working backwards here, take F and substitute it into G. Working inside out, take F and substitute it into G. So some textbooks or problems or exams, they use different notation, but I want you to be aware that these notations are exactly the same thing. Different symbols that mean the exact same thing. So let's do a couple more problems. Number 3, find f of g of x. This means to take our g, which is 2x squared plus 5, and I'm going to substitute that into f. When you make a substitution, your variable is no longer there. You're getting rid of it, and you're replacing it with 2x squared plus 5. Sometimes it may be helpful to circle and kind of draw arrows so you can see what you're substituting in. So I am substituting 2x squared plus 5 into x because it says to take g and plug it in. We're doing function composition. So I keep the 3, plug in 2x squared plus 5, add to 2. Okay. So 3 comes down. I made a substitution, which is what g is, and the plus 2 comes down. Now we do the distributive property. This is going to give me 6x squared plus 15 plus 2. Again, if you need to put arrows up here at the top to keep track of where you're multiplying, there's nothing wrong with that. Combine like terms, we get 6x squared plus 17. Now, I only had to do one direction because that's all that the problem asked for, which is absolutely fine. It told us to find f of g of x, so we went one direction, and the direction we went was to take g and plug it into f. Now, let's take a look. And this time, we're going to take f and plug it into g because that's our symbol, our notation that we have here. Work inside out, take our f function and plug it into g. So this is our f function. We're going to take that and plug it into g. So that means that I'm going to start with some parentheses. I'm going to plug in f, which is 4x minus 3 squared, add 3 to it. So I got rid of this x. I replaced it with the function, which was 4x minus 3, but I still have the squared, and then add 3 to it. So this is the first one we see. We're going to have to go through and do box method, for method, some sort of way to multiply this out. So I'm going to do that off to the side, box method like we reviewed a few days ago. If you don't like doing box method, you're more than welcome to do the distributive property. So 4x minus 3 times 4x minus 3. This is going to give me 16x squared minus 12x minus 12x plus 9. So if I come back and add that into my problem, make sure we combine like terms. The square term comes first because nothing went with it. Add these two together, that gives us negative 24x. And this gives me plus 9. and do like terms. So my final answer should be 16x squared minus 24x, and 9 plus 3 is 12. So g of f of x, we took the 4x minus 3, which was f, and we made a substitution into the problem right there. And I do have one more that I want to take a look at just to make sure we have plenty of examples. So let's take a look at this one. So find g of f of x. Making sure we understand notation. This means to take our f function and substitute it into g. Take f and substitute it into g. So this is our f, and we're going to have to make two substitutions. We're going to have to substitute it in for this x and work it out, and substitute it in for this x and work it out. So we're going to have to do that two times. So we're taking negative 3x plus 2, what I circled there, that's our f function. We're going to substitute it in right here, and we're going to substitute it in right there. We're making two substitutions. So that's going to look like negative 3x plus 2 squared plus 2 times negative 3x plus 2, and then add 4 to it. I got rid of the variable. I replaced it with negative 3x plus 2, but I still have to square it. Kept the plus sign, kept the 2, plugged in negative 3x plus 2, and then added 4 to it. A good habit to do is just to go ahead and put parentheses around whatever you're making a substitution around. That way you know that you made a substitution. Off to the side, we're going to have to do the box method or the FOIL method here. So I'm going to set up my box, negative 3x plus 2. So you can do box, distributive property, or FOIL method. I generally don't do FOIL because it doesn't work for trinomials, but it'll still give you the same answer in this case since I'm working with binomials. So this is going to give me 9x squared minus 6x minus 6x plus 4. I go through and I'm going to add this back into my problem. So this was kind of like a side note because I had this squared. So I'm going to add my answer back into my problem. That's going to give me 9x squared. This gives me 12. And plus 4. I got to go through, do distributive property here. That's going to give me 2 times negative 3x is negative 6x. That's going to give me plus 4. And then I had a plus 4. So this gave me the negative 6x. This gave me the plus 4. And I had an additional plus 4 that needed to come straight down. So the work for this is off to the side. Right here, I did box method. You're more than welcome to do distributive property. And here, I did distributive property. Now, the only thing left to do is combine like terms. I only see one square term, so that needs to come down first. I see 2 linear terms that go together. That's going to give me negative 18x. And I see a 4 plus another 4 is 12. So this problem was a lot longer than the other ones that we previously did because I had to make 2 substitutions.